All right, so we're going to look at 7-1 and 7-2 today, all on systems of equations. So we're going to focus on substitution and the elimination method. So a lot of what we're doing today should be review. So I'm going to go through the substitution really quickly. There is a back to this, just to let you know. This is the one that has some new stuff in it. On my notes online, it has a lot more notes to self than what I'm going to make you right here. So just, if you want to go out and print out those notes so that you have more detailed notes, you're welcome to do that. However, I still want you to take notes here with me today. All right, so let's look at the substitution method. Anybody remember what you do? Yeah, it's running constantly and it's really loud. So if you try to talk to me, I can't hear. It's been running all day long, which is never a good thing. It's code for it's gonna break. It was freezing in here this morning. All right, so what do I do with substitution? What's my goal? No, I don't want to eliminate. I want to use substitution. And you do need to understand that if I say solve by substitution and you use elimination, you will get very little credit. You'll get credit for the answer and no credit for the work because I'm testing on do you know that method. So do bear that in mind. To what? Nope. Okay. So you want to solve one of the equations for x or for y. You need to be smart about what you're solving for. For instance, I would not solve the top equation for x because I want to avoid fractions at all costs. The only time I would use substitution is if one of my coefficients was 1 or negative 1. So I want to look for the variable term that has a coefficient of 1 or negative 1, and isn't that the one right there? Sometimes you have a choice, maybe you have more than one, you know, that has a coefficient of 1 or negative 1, but in this case we only have 1. So we're going to, number 1, we're going to take 2x plus y equals 5, and we're going to solve it for y. If I solve it for y, what do I get? You could put this one in the slope-intercept if you want to, or because we're not graphing it, you don't need to worry about that. So if I subtract 2x from both sides, I can write it as 5 minus 2x, or negative 2x plus 5. It's your choice. So then I'm going to take this value, because this is what y equals, and we're trying to find the ordered pair that these two have in common. So they both have the same y and the same x in common. So if this y is equal to 5 minus 2x, then this y right here is also equal to 5 minus 2x. So then my second step is to take the other equation. You cannot substitute back into the equation that you solve for. You'll get an identity. You have to sub into the other equation what we just solved for. So 5 minus 2x goes in here equals 4. Now I have one equation, one unknown. So distribute your negative 2. Collect like terms. Add a 10, and divide by 7. Is that my answer? Nope. Then what do I have to do? Plug it back into one of the original two. Which do you think would be easier to plug into? Yeah, the first one. So then I'm going to plug back in 4x. I'm going to replace it with the 2 plus y equals 5. So I get 4 plus y equals 5. Doesn't y have to equal 1? And then finally, you have to write out your answer. If you leave your answer this way, you're going to lose quite a few points because you shouldn't leave it up to me to figure out what the answer is. You need to write it as an ordered pair. And so x comes before y, so we have 2 comma 1. So this one only had one solution. Those were both linear equations, right? So then I must have had intersecting lines. You might get a parabola and a line, or you might get 2 parabolas. So now that you're in pre-calc, it's not just linear equations. So look at example 2. Is it getting nicer? There we go. So example 2, I have, isn't this going to be a parabola here? Because it's a quadratic, and then this is a line. So I have a parabola, and this parabola probably opens up, and then I have a line, it could go that way, it could go negatively. But at most, how many times will this line intersect the parabola? Twice. Could it intersect no times? Yep. How about one time? Yes. If it intersects where at? The vertex. So this line could either be the line of symmetry, right? Or it could be perpendicular to the line of symmetry, like right here. So it's either a horizontal or vertical line. That's the only way that, in this particular case, it would intersect just once. So let's see what we have. What do you want to solve for? I personally would solve the linear equation for its y. I would not solve this equation for its y. So I would actually solve for this y here. It'd be easier. Question? I guess. We don't usually go to the bathroom in the middle of my lectures, just to let you know. Alright, so step 1, we're going to solve this. Subtract x from both sides, so I get negative y equals negative 2x minus 1. And then I want to solve for positive y, so I'm going to multiply everything by negative 1. So it changes all signs. So then this value for y gets plugged into the other y right there. But be careful, what's in front of that y? A negative. So you have to use substitution parentheses when you're subbing in. So step 2, I've got x squared plus 4x minus, in parentheses, I'm putting in 2x plus 1 equals 7. So x squared plus 4x, distribute that negative, minus 2x minus 1 equals 7. What should I do here? Combine like terms, and I'm going to move the 7 to the left, so I have one side equal to 0. I have a quadratic. That implies I'm going to have to factor. So I have x squared, 4x minus 2x is 2x. If I subtract 7 here and subtract 7 here, don't I have a minus 8 equals 0? You okay with that? Are you with me, Dan? You're zoning out on it. Then from here, I want to factor this quadratic into two binomials. So in my t-chart, I'm going to take 1 times negative 8. I get a negative 8. So that means I'm subtracting the factors of 8. I'm looking for my middle term of positive 2. So what factors of 8 subtract to give you 2? 2 and 4. My sign of my middle term is positive, so the bigger of the two gets the plus. What's the 2 going to be? Negative. Because my coefficient here is 1, I can shortcut it and just throw the x squared here, x and x, the minus 2, and the plus 4. So I'm going to have two values for my x. So that means that my line crosses the parabola in two different places. I'm going to have two different ordered pairs as my solution. So one of my x's, if I set this equal to 0, is what? 2. And if I set this equal to 0, negative 4. So then step 3 means that I want to sub back into, I personally would sub into the linear equation to find my y's. So we have to do it twice. So 2 times 2 minus y equals negative 1. So 4 minus y is negative 1. Subtract 4, subtract 4, I get negative y is equal to negative 5. And then doesn't y equal 5? So there's 1. Do the second one. 2 times, and instead of x, I'm putting in negative 4. So 2 times negative 4 is negative 8, minus y equals negative 1. Add an 8 and add an 8. 8 and negative 1 is 7. Multiplied by negative 1, y is equal to negative 7. So for my two answers, step 4, when x was 2, what was y? Right there, 5, right? And when x was negative 4, what was y? Negative 7. So those are my two solutions. Sure. All right, so let's look at the Word problem below. Thank you. All right, so this time we have a total of $12,000 is invested in two funds. So we have a total of $12,000 is invested. One fund pays 9% and the other is 11% simple interest. And then they talk about the yearly interest is $1,180. We have two different equations going on here. One equation for total investment and one equation for total interest. So let's do a 4-step plan. We are going to let, what are the two things that I don't know? What's the question asking for? What do you have to find? How much is invested at each rate? How many rates are there? 2 rates. So we're going to let X equal the amount invested at 9%, and we'll let Y equal the amount invested at 11%. So you have two equations, one equation for interest and one equation for the total invested. So you have this 12,000 and this 1180. If you knew how much was invested at 9% and how much was invested at 11%, and you know that total you have 12,000, what's your equation? This has to be less than 12,000, that has to be less than 12,000, but together they have to be what? So together implies not doing what? Adding. So one equation is going to be X plus Y equals 12,000. This is a very, very, very common type of problem. Then we need to calculate interest. How do we calculate interest? Simple interest. Let's say that we have $100 invested at 10%. How much interest are you going to get? $100 at 10%. $10. How'd you get that?
Because $10 is 10%.
So wouldn't I do 100 times 10%? So wouldn't I take my amount invested times my interest rate? Right? So to calculate interest, I'm going to take my amount invested, which in this case we'll start with X. What's the interest rate for the X? 9%. But we're not going to put 9, we're going to put 0.09. Because I would multiply this amount by 0.09. Then wouldn't I add the interest that I'm going to earn on the Y investment? So how are you going to write that? 0.11 Y. Because you only moved it 2 places, right? Equals, how much interest will these add up to? $1,180. So then here you have a choice. You can either solve the top equation for X or the top equation for Y. Does it matter which one that you choose? It makes no difference. So let's solve for, we've always solved for X first. Oh no, we solved for Y on both of them. So let's go ahead and solve for X. Because we solved for Y on the other two. I don't want you to get in the habit of always solving for Y. So then we're going to go straight down and we're going to solve. So here's my system. We're going to solve this equation for X. So what does X equal? Subtract Y from both sides. 12,000 minus Y. So this amount right here has to go into the other equation for that X, and I'm going to use substitution parentheses. So this was step 1, so now step 2. 0.09 times, instead of X, I'm putting in 12,000 minus Y plus 0.11 Y equals 1180. Yes. So we are going to break out the handy dandy calculator. Getting nervous there, weren't you? Even I don't want to do that on the or by hand. So 0.09 times 12,000 gives me, oh look at that, 1080. Whoops. So that's 0.09 times this, then 0.09 times negative Y gives me a minus 0.09Y. plus 11/100ths y equals 1180. So combine your like terms, right? So I have 1080. What do I have when I combine these two? Plus 2/100ths y equals 1180. Subtract 1080 from both sides. What do you get? Don't you get 100 if you subtract 1080 from both sides? And then divide both sides by 0.02. So 100 divided by 0.02. $5,000. So if y is $5,000, what's x going to be? Yeah, so plug it into here. X would have to be $7,000. And so now you can answer the question. Therefore, $5,000 was invested at, and so since 5 was y is 11%. So 11%, and $7,000 was invested at 9%. Deja vu, right? Do you wish you had this before the econ quiz? No? Alright, so then we're going to look at example 4 and 5, which is using the graphing method. Oh, by the way, we're doing the graphing method too. So some of these you're going to want to use your calculator, some not. I mean, if it's a parabola or if it's a linear equation, you ought to be able to graph it without use of your calculator. Now, I will allow you to do certain things so long as you show me certain vital points, because I'm not going to necessarily take your calculator away from you. So this one, you should recognize that one, right? Way, way long ago. Remember this one? Doesn't it go like this on your graph? And isn't the most important point, the only point we usually generally graph on this, wasn't it 1, 0? So this one starts here at 1, 0, and it goes like up this way and down this way. I'm going to hold off graphing that until I see what the other graph is, because I want to see where the two graphs intersect. Is this in the proper form? What kind of graph is this? Linear, quadratic, cubic, what is it? Linear, so it should be a straight line. So is that in the proper form for graphing? So it's y equals what? Negative x plus 1. So what's your y-intercept? Positive 1. What's your slope? Negative 1 over positive 1, right? So down 1, up to the right 1. Don't they intersect there? Down 1 to the right 1. Down 1 to the right. Down 1 to the right. Fill in the whole graph as far as you can go. 1, 0 is always on our graph of our natural log and the graph of our log. Remember we had a specific point that we always plotted. For natural log, it was 1, 0. For the regular log, it was 0, 1. And 0, 1 went in this direction, right? So that's our critical value. Yeah. So for this one, for natural log, I'm going to go ahead and plot it how it normally sort of looks, knowing that it's intersecting there anyway, which is why I held off. And then I'm going to use a straight edge and connect the linear equation. Now, if you want to graph these on your calculator and double check, and see if your graph is correct, feel free. So I'm going to go into y equals, clear out anything that might be in there. Now I'm going to put natural log of x. Where's your natural log on here? Above your 4.
Near the 4.
Yeah, near the 4. Oh, so you can't see it on there. So right here's your natural log. So natural log And then I want to put my x in there. And then for the other one, I'm going to write it in slope-intercept form, so negative x plus 1. So there's the natural log, and there's the linear function. So how can I tell where they intersect? What table? Calc, right? What are you going to use? Intersect 5, right? Intersect. And so it's flashing. Do I see a flashing light? First curve. Where's my flasher? Oh, there it is. I can hardly see it. Okay, so there's, I just want to see where it is. So there it's flashing. You can see it there. I'm going to press yes. Second curve, it's now shot right up here, so I'm going to press yes. And then guess. Is that where it intersected? Sure enough. So that is our answer. So our intersection is 1, 0. So that's our solution. This only has 1. Then, example 5, we have a quadratic, which is a parabola, and a linear. So let's start with a linear. It's always easier. So we're going to solve this for y. So that's my first goal. So negative y is equal to negative 2x minus 1. All I did was subtract 2x from both sides. Then I want to get the y by itself, so multiply everything by negative 1. Y is equal to 2x plus 1. So where's the y-intercept? Positive 1. And the slope? Yeah, so the slope is 2 over 1 or negative 2 over negative 1. So you have to go in 2 positives or 2 negative directions. So up 2 to the right 1, up 2 to the right 1, or down 2 to the left 1. And then you're going to connect those points. Then for your parabola, is this a parabola that opens up or down? Up. We haven't gotten our conics yet, but I'm more than happy on this one just to let you throw it in here. But you have to find your important points. What are your important points on the parabola? Your vertex, your y-intercept. Well, you can tell your y-intercept right here. What is it? Negative 7. So I already know that this is going to cross it like right down here. I'm a little off on my graph. So I'm going to go ahead and throw these in here. And then the next one. What's my first problem? Yes.
I just have a good question.
Yeah.
It's a little off topic, but you know how there was like that the NASCAR crash?
Okay, we can't talk about that right now.
Oh, I was just wondering just if we could like study it later.
I don't know, we'll see if we have time. But right now, I gotta finish
Yeah.
this, and we'll talk about that in a minute. Alright, so the first thing I want is my vertex. Can I see it on my graph? No. How can I find my vertex? So I want to go to my calc menu, and I want my minimum, because this is a minimum value, right? Because it opens up. So I'm going to hit minimum 3. And so we're going to go... Uh-oh. There we go. Okay, so I want to get it on my parabola, which I'm having trouble. Alright, so let's go back up here to y equals, and we're going to get rid of, just go over here and put your cursor on your equal sign and hit enter. The lamp has reached the end of its usable life. Okay, thank you for telling me. Then go back into your graph and you should only see your parabola. So now let's go back to calc, minimum, left bound, yes. Okay, so you can kind of see it blinking right over there. So hit yes, then right bound and move it to the right of the vertex. hit yes, and then guess. So that gave us, it's close to what number? -2, -11, right? And that's kind of far off our graph, isn't it? So -2, this is 7, 8, 9, 10, oh, okay, so it'd be like way down here somewhere, right? But this is my axis of symmetry. Isn't this point right here 2 units away? And so can I go 2 units to the left? Guess what happens here? 1, 2, to the left 1. Isn't this one of my intersecting points that's off my graph? So my line should be intersecting here on my parabola. What ordered pair is that? What ordered pair is this? This is 2, right? So 1, 2, 3, 4. -4 what? -7. That should be one of my intersecting points. Then, what are the other critical values that I should graph on here? How about where the parabola crosses the x-axis? How can I find those on here? So go to your calc menu. What are you looking for? Zeros. So you're going to hit 2. And so they want left bound. So I'm going to find my left 0 first. So I'm going to go above the x-axis, hit enter. Then I'm going to go below the x-axis, hit enter, and guess. And I get -5.30. So I'm going to go slightly. Here's 2, 3, 4, 5.3. It'd be about there, right? And then I'm going to find the other 0. They want left bound, so this time I'm going to go under the x-axis. There we go, hit enter. And then above the x-axis, hit enter, and then guess. So that one's about 1.30. So was this one factorable? No. All right, and then it's going to end up hitting my line someplace else. So I'm going to hold that thought, because I already know I have this as one of my solutions. I need to find my other solution. So I'm going to bring back my line that we took away. So go to take your cursor on the equal sign and hit enter so that it's lit up again. So when you hit graph, now you should see both graphs. Now I want to check this intersection down here to see if it really is -4, -7. So I'm going to go to calc and I'm going to hit intersect 5. And they want the first curve. I'm going to bring it down closer to where the intersection is because I don't want it to get confused and do this intersection yet. So I'm going to hit the first curve there, so yes. And then the second curve, I want to get to my second curve. Yay. Seriously? Hang on. Gosh, it still did it. That's weird. Hold tight. Alright, so I did intersection again. So it's hitting first curve, it's flashing right there. So I hit enter, and it should pop it there, it's popping up on the second curve. I think they were just too close for me to see it, so I hit enter and then guess. What point did it give me? -4, -7. Abby, are you okay? Second intersection, so I want to go to intersect 5. So move your cursor closer to the other intersection. So hit enter. Now it's flashing down here, and you want to hit enter again, and then guess. This time it gives me what? Are you guys dead today? 2-5 to do today. You've had actually nothing to do. So here's the other intersection. So I can now kind of graph my parabola. I'm doing a really terrible sketch job. Do that. Yeah. And so this is what? 2, +5. So there's one answer and there's the other answer. All right, so then last question on here is the word problem. A small business invests $10,000 in equipment to produce a product. Each unit of the product costs 65 cents to produce and is sold for $1.20. How many items must be sold before the business breaks even? So we're not gonna put our graph on the paper, but we can put it in the calculator. So again, I have two unknowns. How many items must be sold before the business breaks even? So I don't know the number of items. And what am I looking for? I don't even know if I probably wouldn't even do this with two unknowns. We're gonna let X equal the number of items.
You're just doing this
Huh?
and like you were there.
Yep. Well, okay, so then how do you find the cost? General form, how do you find the cost of a business? They have fixed costs and they have variable costs, right? What up there do you see as a fixed cost? Isn't the $10,000 their fixed costs? No matter how many items that they produce, they're still gonna have to fork out that $10,000. So that's gonna be, and I would put here plus fixed costs. And then the cost would be, I guess you can call this cost per item. Right? And so doesn't it cost $65 to produce each item? And here they're giving you the selling price, so you can find how much they're making off of each item. Well, part of the break even is taking into account these fixed costs. I have to make back that $10,000 before I can actually truly start making money. And so my profit, I guess my revenue, is equal to the selling price per item. In this case, $1.20 times X. So we want to find out when does cost equal our revenues. So our cost is going to be 65 cents. Whoops, that's supposed to be a 5. Times X plus the $10,000, right? Equals, and our revenue is going to be $1.20 times X. So $1.20 per item, that's how much we're making. This is how much it's costing us to make them. We could graph those as separate equations, and then we could look at our y equals on here, or we can solve this algebraically too, can't we? If you were to graph it, it's going to look like this. So clear these out. So I'm going to put 0.65 x plus 10,000, and then here I'm going to put 1.2 x. Now we're going to have an issue with our window, aren't we? If we sell no items, if we make no items, how much is our cost? $10,000, right? So look at what happens with our window. We're missing a graph, aren't we? So let's go in here and go to window. Actually, I'm going to do zoom. Let's just see what zoom fit does. That didn't help us much at all, did it? All right. We're going to take our X. So are we going to sell negative items? No. So I'm going to go ahead, I'll leave it -10, but that's why they did that, just so you could see the y-axis. Max, I don't know. Let's go out to 100, because perhaps it's 100 items that we need. Our X scale, we'll see what that does. Could we have a negative dollar amount? Well, technically, if we sell no items, we have a loss, don't we? All right, so we'll go with negative $10,000. And our maximum is going to be 12, we'll go with 20,000. Let's just see what that does. Seriously? Yeah, it's so, yeah, they're so close we can't see them. So let's go ahead and just solve it algebraically. What are you gonna do? 10,000 is equal to what? What's 120 minus 65? You can't do that in your head. Alright, then how are you gonna solve? 10,000 divided by 0.55, and so we get x is equal to 1,000, oh, 18,000, sorry, oopsies, 181.82. Isn't that items? So if we sell 18,181 items, will we break even? No. Why? Because we're just slightly short. Don't we have to sell 18,182 items to break even? Because we can't make a partial item, right? So therefore, I wish the lamp thing would be gone. It's really annoying. Therefore, you would have to sell 18,182 items to break even. Alright, then zip out 7-2. I'm really not going to do a whole lot with 7-2 other than 100% of 7-2 should be review. Can I take this away? So let's talk about number 1. With elimination, don't you have to decide to get rid of your x's or your y's? You make that choice. So as we look at these two, I would get rid of my y's because I have a positive and a negative already. And I'm going to have to multiply both equations by something anyway. What are you going to make 3 and negative 4 into? 12. So that means the top equation has to be multiplied by 4 and the bottom by 3. I don't have to multiply by a negative because I already have a plus minus. I would suggest you rewrite the entire equation, or the entire system. So I get 20x plus 12y, and don't forget to do 4 times 9 is 36. And then multiply the 3 through. 6x minus 12y is equal to, and then 3 times 14 is 42. Then you ought to be able to eliminate one of your variables. And I get 26x is equal to 78. And if I divide 78 by 26, I do get 3. Stop cracking your gum. If it doesn't go in there evenly, you need to leave your answer as a fraction. Then you decide if you want to plug 8 into the top or the bottom equation. In this case, it really doesn't matter. I'm going to choose to plug it into the top one because there's no negatives. So I'm replacing x with 3. So we get 15 plus 3y equals 9. Subtract 15, 3y is equal to negative 6, because I'm subtracting 15. Divide by 3, you get negative 2. So what's your answer? You have to write it out alphabetically, so 3, negative 2. Is there, oh, sorry, I know the lamp's in the way. I can't make that thing go away. Alright, so then let's look at number 2. What's smart to get rid of here? I would get rid of the x. Even though this has a plus or a minus, this you'd have to multiply both top and bottom by something, but here, can't I multiply the bottom equation by a negative 2 and I'd have less work? So the top equation doesn't change, I'm still going to rewrite it, but the bottom equation becomes negative 2x minus 4y equals negative 10. So now my x's cancel. I have a negative 7y equals negative 7. So shouldn't y equal positive 1? Plug that into, I would plug it into the second equation. X plus 2 times 1. So I get x plus 2 equals 5, x has to equal 3. So your answer is 3, 1. Example 3. Yeah. Yeah, right? Okay. So example 3, are you going to get rid of x's or y's? Either way, you're going to end up with kind of the same answer. So let's get rid of x's, just for chuckle's sake. Wouldn't I only have to multiply the top equation by 2? I end up with 4x minus 6y equals 6. And the bottom equation is negative 4x plus 6y equals 6. Both the x's and the y's cancel. What are you left with on the left? 0, right? What are you left with on the right? 12. Is that a true or false statement? Since it's false, what's your solution? No solution. If it were true, what would be your solution? What kind of lines are these if it's false? They have no intersection. Parallel lines. Last one. And I do know we're going to run out of time. I would get rid of, it doesn't really matter, multiply the top by 2. Watch what happens. So you get actually a negative 2, right? You get a negative 4x, a positive 6y, and a negative 6. This time, when everything cancels, don't you get 0 equals 0? That's true. Your solution is all real numbers. I did that in record time. Score.